The directions say to evaluate the integral. Let's take a look at example 1. Suppose I have the integral of sine squared x times cosine of cubed x dx. Now, notice how cosine of x is raised to the third power, which is an odd power. And so remember that cosine cubed x is equal to cosine squared x times cosine x. And so I can write this integral as the integral of sine squared x times cosine squared x times cosine of x dx. Now, this is important. We know that sine squared x plus cosine squared x is equal to 1. Solving for cosine squared x, we get 1 minus sine squared x. So here we can write the integral of sine squared x times 1 minus sine squared x times cosine of x dx. And now we're in a perfect position for a u substitution, because I'm going to let u equal sine of x. du is cosine of x dx. So this integral can be written as follows. It's the integral of u squared times 1 minus u squared du, which is the integral of u squared minus u to the fourth du. I just distributed the u squared inside, which is 1/3 u to the third minus 1/5 u to the fifth plus c. But remember that u is sine of x. So this is 1/3 sine cubed x minus 1/5 sine to the fifth x plus c. That's how we do example 1. Let's take a look at example 2. Suppose we have the integral from 0 to pi over 2 of sine to the 7th x cosine to the 5th x dx. Now, notice how sine of x is raised to an odd power and cosine of x is raised to an odd power. Now, we want to save off either a sine of x or a cosine of x, and I claim it really doesn't matter which one. So I'm going to look at cosine to the 5th x. And I'm going to write this as cosine to the 4th x times cosine of x. So notice in each problem I saved off a cosine of x. And so I can write this as the integral from 0 to pi over 2 of sine to the 7th x times cosine to the 4th x times cosine of x dx. Your next goal is to express cosine to the 4th x in terms of sine of x, because what I'm trying to do is set myself up for a u substitution. So this is the integral from 0 to pi over 2 of sine to the 7th x times 1 minus sine squared x raised to the 2nd power times cosine of x dx. Now, let me explain this real quick here. Remember that cosine to the 4th x is cosine squared x raised to the 2nd. And just like in example 1, what I did was I took cosine squared x and wrote it as 1 minus sine squared x. And That's where I got that third line. So let u equal sine of x du is cosine of x dx. Now, we have to change our limits from x limits to u limits. So don't forget, when x is 0, I get u equals 0. So I'm plugging in here. And then when x is pi over 2, u is 1, because remember, sine of pi over 2 is 1. And so we get the integral from 0 to 1 of u raised to the 7th power times 1 minus u squared to the 2nd du. And so this is the integral from 0 to 1 of u to the 7th times 1 minus 2u squared plus u to the 4th du. And I'm going to distribute that u to the 7th inside. So we get the integral from 0 to 1 of u to the 7th minus 2u to the 9th plus u to the 11th du. So this is 1/8 u to the 8th, okay, minus 2/10 u to the 10th. But remember, 2/10 is just 1/5. And then I'm going to go plus 1/12 u to the 12th. And I'm going to evaluate from 0 to 1. Replacing u with 1, we get 1/8 minus, if you don't mind, I'm going to say 2/10 is the same as 1/5. So I'm going to subtract off 1/5, and then I'm going to add 1 over 12. So far? Okay, then the question becomes, what is the lowest common denominator between 5, 8, and 12? Okay. Now, remember 8 can be written as 2 to the 3rd. So this is old school. And then 5 is already prime, so I'm just going to write 5 equals 5. And 12 is 2 to the 2nd times 3. And so the LCD is going to be 2 to the 3rd times 3 times 5, which is 120. So I'm going to put 120 here. 8 goes into 120 15 times. 5 goes into 120 24 times. And then 12 goes into 120 10 times. So the answer here is 1 over 120. And that's how you do example 2. Let's take a look at example 3. Suppose I had the following. Suppose I had the integral from 0 to pi over 2 of sine squared x times cosine squared x dx. Okay, so this one's a little bit trickier only because the power of sine x is 2 and the power for cosine of x is 2, and 2 is an even number. And so we can't save off a sine of x or a cosine of x. So the question becomes, how do we do this? Now, recall, sine squared x is 1/2 of 1 minus cosine 2x. And cosine squared x is 1/2 of 1 plus cosine 2x. So the integral from 0 to pi over 2 of sine squared x cosine squared x dx can be written as the integral from 0 to pi over 2 of 1/2 of 1 minus cosine 2x times 1/2 of 1 plus cosine 2x dx. But remember that a half times a half is a fourth. So this is 1/4 the integral from 0 to pi over 2 of 1 minus cosine squared of 2x dx. But 1 minus cosine squared of 2x is equal to sine squared of 2x. So this is the integral from 0 to pi over 2 of sine squared of 2x dx. And I'm going to use the power reducing formula on this again. So this can be written as 1/4 the integral from 0 to pi over 2 of 1/2 of. Now, the pattern is I'm going to double whatever this angle is. And so I'm going to write this as 1/2 of 1 minus cosine of 4x dx. But 1/2 times a fourth is equal to 1/8. So this is 1/8 the integral from 0 to pi over 2 of 1 minus cosine of 4x dx. So we get 1/8 times the quantity x minus 1/4 sine of 4x evaluated from 0 to pi over 2. If I replace x with pi over 2, I get pi over 2. And remember, sine of 2 pi is 0. And then when I replace x with 0, I get 0. And so the answer here to this question is 1/8 times pi over 2, which is equal to pi over 16. And that'll do it for this video where we integrated powers of sine and cosine, and we looked at 3 examples. Thank you.